All right, this lab is just to show you a good visual of what happens in the different types of lenses. If you remember from your last set of notes, it was about convex lenses versus concave lenses. So I have one of each here, my light blue lens and my dark blue lens. I started this first set right here is with the light blue lens, and that is going to be important, so make sure that you're adding that label to your diagram here in a bit when you draw it all out. So what I've done is I took my lens and I placed it on the paper, traced it so that anytime I wanted to pick it up or if it got moved I could always put it back in the same place. I have a laser, okay, so you can see the red beam with a little holder, and all I did was I shined my laser beam through the lens at various positions, and each one of those times that I shined it through represents a single ray of light. And you can imagine all the light rays that are entering the lens are doing this exact same thing. We're just going to visualize it. So I didn't want you to have to watch me draw a bunch of dots and trace a bunch of lines, so I've started it already. What I've done is I put a dot where the beam came out of the laser, where it entered the lens, where it came out of the lens, and then where it hit just a block that I put at the end of my paper. And I've traced the beginning part here. They should be relatively parallel to each other. They're not perfect. I never seem to end up with as good a result at home as I do at school, but you work with what you got. So all of my light rays basically are parallel going into the lens. Now we know from our notes that something is going to happen to those light rays once they come out on the other side of the lens. So that's what we're going to trace now. I've got 5 different colors, and we're going to just trace what happens to each of these rays when they come out the other side of my lens. And we can already see just from that first line that it's bending. And the second one. And what we're looking for here is not just the fact that they're bending, because we knew that they were going to bend when they came out of the lens, but we want to see where are they going. What they're doing is called converging. If you remember from your notes, to converge means to come together. So not only are they all going to bend, they're all going to converge. They're going to cross over each other at some point. Now again, not perfect. But you can see that they've all started to cross and come together right about in this area right here. So I'm going to find the place where I have the most crossover, and that is right about here, and I'm going to label that as my focal point. If I had an object over here that was projecting an image, or that an image was appearing, this would be where my image would appear. So, but this is where all of my light rays come together. And now I want to measure that. I want to see how long or how far away is my focal point. So I'm going to put the 0 end of my ruler right where the middle of my lens would be. And I'm going to measure straight out to that point. And this is telling me 20.5. So I'm going to write here 20.5 centimeters is my focal length. And we also know that because our light rays are converging in front of the lens, this is what we call behind, where our light starts. This is in front of, where it ends. So our light rays are converging, so we know that that makes this a convex lens. Make sure you add that to your diagram. Now, those of you that are trying to draw along with me, as it says in your instructions, I will give you a better view of the diagram as a whole after I finished. I just don't have a great camera angle to be able to see the whole thing without me holding it. So, that's our light blue lens. We know it's a convex because our light rays converged. We found our focal point, which gives us our focal length, that distance right there, of 20.5 centimeters. Now we're going to look at the second lens. Now our second lens is what I'm calling the dark blue lens, and again, you're going to need to know that for your quiz. So I've done the same thing. I started off with my 5 roughly parallel light rays at the beginning. Not perfect, but we work with what we've got. And now I'm going to trace where those light rays ended up. On the very first one, right away we can see that it's doing something different. So we can see now it's bending away from that center point instead of towards it. So let's go ahead and trace all 5 lines. And we can still measure a focal length on this, we just have to do it a little bit different way. So after I've got all of my lines traced, then I'll show you how we would go about trying to find the focal length of this kind of lens. And one more. Get a nice wide bend. Okay, so clearly our light rays are diverging. They're bending apart from each other on this side of the lens. So a focal point is where all the light rays come together or converge. So how do we do that? Well, for this kind of lens, what's going to happen is the image or the focal point would be in front of or behind the lens on the same side as our light source. So what we can do is take our ruler and that light ray that we just traced over here, we're going to extend it back behind the lens. And I'm going to do it in a dotted line so that it stands out a little bit and we can see the difference. And I'm just going to go nice all the way out to the end of my ruler. I'm going to do that with all 5 of these lines. Line up the ruler with the ray that I drew and just extend it out on this side. It's getting a little crowded over here behind this lens, but we'll be able to see a nice converging point. 2 more. And the last one, nice and wide. So when you look at how all of those rays now converge on this side, we can say approximately right about, let's say right about here. And it's a guessing game because they kind of hit in different places because we never get a perfect result when we're doing stuff, when we're eyeballing things. But I think it's going to be not so bad. So now to measure our focal length, we do the exact same thing. Start from the middle of the lens and measure out to where they come together. I'm going to put my 0 this time on that line that we marked. And to the center of my lens is 14.8 centimeters. So focal point right here, and 14.8 centimeter focal length. Now the last thing that I'm going to do on camera here is we'll talk about what kind of lens this is. So we know that the light rays came in. Once they hit the lens, they diverged, or they spread apart, and that is our clue to tell us that this is a concave lens. So our light blue lens was convex, our dark blue lens was concave. Now I'm going to move the camera, so forgive my camera skills here, so that y'all can see both diagrams. So here's our light blue, and you can see the straight lines going into the lens on the left, converging to that focal point on the right, and the dark blue lens, straight lines coming out from the left, diverging on the right. They all spread apart, and then we trace them backwards to find our focal point over here. And one more thing that I'm going to add on here that's going to be important later. When our image or our focal point appears behind the lens like it is here, we're going to give that a negative. That's just an indicator that we're opposite from where we would normally be. So we would expect our focal point to be in front of the lens here, so that's a positive focal length. It's behind the lens over here, so it's a negative focal length. All right, make sure you have all of this copied into your journal as best you can. Doesn't have to be perfect, just as long as you've got the basic idea. Make sure that you read the questions on the lab quiz really carefully so that you can do the best job you can, and let me know if you have any questions. Have a great day.